Thank you for coming today. I'd just like to give you a little bit of a background about REA. So REA originally stood for Renewable Energy Advisors. So we started in the solar industry back in 2006, advising solar companies, government, and big projects globally through Germany, Spain, Czech Republic, where renewable energy really started to kick off in the early 2000s. And then we brought on our in-house engineering team and changed it to Renewable Engineering Australia. So we started as advisors and then installers and a retail business just like Luke, and then started to develop with our R&D team and manufacture our own technology. So REA, in terms of in Australia, established in 2010 the Renewable Engineering Division. We've done over 30,000 installations in Australia. We have over 20 plus years experience with our team in renewables. To give you a bit of an idea of how long we've been in the business, when we started it was $16,000 for a 1 kilowatt system. You got $8,000 from the government and you put $8,000 towards it. So, and I think the cost of power back then was about 15 cents. So you can imagine how long it took to return your investment. So proudly engineered in Australia. We work and we really appreciate our research projects with Oz Industries, Central Queensland University up in Gladstone, and University of Queensland as well at St Lucia. I work quite closely with Dr. Paul Byrne, who's a fellow who in UQ. He's originally Oxford, and he is one of the leading engineers in photovoltaics and optics. So he works closely with us. And also Sanath up in Central Queensland University. So this is a bit of a funny picture, but the future is the REA Mega Factory. So we do partial manufacturing and assembly in Australia, in Brisbane, and we're looking to bring on our between 800 megawatt and a 1 gigawatt fully automated manufacturing facility in Brisbane and potentially up in Gladstone within the next 18 months. Okay, now our module that we have launched in Australia and also the UK is an AC module. So I wanted to talk a little bit about the differences between DC energy and AC. Now, most solar systems out in the market are DC. So essentially, they're DC solar panels that are connected in series down to an inverter that converts the energy to usable AC. We have developed an AC module with our manufacturing partners Enphase, where at the panel, we directly convert the energy from DC into circuit protected usable AC. So we call it old solar, it's original solar technology, and this is basically what DC looks like. So direct current is constant arcing. That's what potentially can cause a DC arc fault. So within the actual DC circuit, if there is a fault or a break in that circuit during the generation of the panels, it will arc and it will catch on fire. Unfortunately, with DC technology, there is no ability to provide circuit protection. So from the inverter to your house is safe. Somewhat from the inverter to your panels essentially is unprotected. So apart from manually switching off the panels at the roof, there is no way to actually circuit protect that cable. So the REA IQ, which is integrating with Enphase, is an alternating current. So we have a 0 point. It's the same as your lights and power in your home. It's connected to a circuit breaker. So if there is any fault or break in the circuit, it will trip the circuit breaker and it will not cause a fire. Any arcing is self-extinguishing within the system. And this is basically what it looks like. And we have parallel wiring as well. So you get the benefit of safety, but also of performance and no single point of failure. Okay, now in terms of the connection and what it looks like, aesthetics, it looks a lot nicer as well because we don't have that big inverter on the wall with all the DC and AC isolators and switches. Essentially, we just have what we call the Envoy, which it's just essentially the monitoring system that connects to your power and connects to the solar. Question?
No AC isolator.
Yeah, so in terms of AC isolator, depending obviously on what area you are in, you may have an AC isolator or you may have your RCBO circuit breaker in your actual subboard or meter box. Okay, so new regulations globally. Obviously, there are many new regulations that are coming into play to look at solving the issue with safety. One of them is rapid shutdown and remote isolation, panel level communication, demand response, and smart grid control. Our systems and our panel complies with current and future regulations globally. So with a DC system, there are certain markets that they no longer comply with because they can't be remotely turned off. Okay, so this gives you a bit of a picture of the panel level monitoring. So the beauty of having an AC module is that we have an MPPT or maximum power point tracker tracking and maximizing the performance at panel level. So what that means is we can give you the overall system output, but also panel level output. So you have that peace of mind and reliability to know that every panel is operating to its maximum potential. And if there is an issue with the panel, it will not drag the whole system down. It won't turn the string off. It will only be isolated to that particular panel. And you can identify it really quickly. So it helps us with maintenance as well in terms of speed of being able to replace that product and get you back online. Yeah, so Luke is just passing around a cell, just showing you the bifacial N-type cell structure. So this gives you an overall system performance. Most solar systems come out with this now as well. So to show you the solar performance, the home energy consumption, and then if you have an integrated battery as well, showing you that charge and discharge rate. So we always recommend when you purchase a solar system to obviously get the online monitoring to show you as much information as possible so you can get the best out of your system. Introducing the Fusion 2. So what makes the Fusion 2 quite unique? There are companies bringing out dual glass modules now. With our R&D and development of our product, we believe that dual glass is the only way to have a module last for over 25 years. So we have glass on the front and glass on the back as opposed to a back sheet, which is normally the #1 cause of a panel failure due to delamination. Now, a conventional cell compared to the REA Fusion. So conventional solar cells, whether it's a P-type PERC cell or an N-type TopCon, which is the updated version of PERC, essentially the cell structure it produces a certain amount of energy. The beauty of our Fusion cell is it's a HJT, which means that we have more bifaciality. So it means that we produce more power on the rear side as well. And the panel itself is transparent, so we're able to get that refractive and oblique light on the back of the panel to produce a little bit more energy, but the focus is about duration. So it's about turning the system on earlier, turning it off later to create more energy for a longer period of time. Okay, this slide's a little bit old, but you've got a conventional panel now. Most conventional panels around that 400, 450 watts. Our 440 watt bifacial module is 440 front, 440 rear, and we actually have what we call a BMPI rating. Now we have what's called a bifacial sun simulator of 484 watts. So what that means is in the right conditions, we can get up to 10% extra performance by using that rear activation. Fusion technology. So we actually have the world's highest output AC module. So what that means is that the actual microinverter that we have is Enphase's highest single microinverter, which is the IQ8HC in Australia. It's connected obviously to a bifacial module to produce the most amount of output. Plug and play. So this is a really good point. Obviously, we've been in the solar industry for over 10 years. We've seen different panel technologies. We've seen different panel setups between the setup of voltage and current. We know that within a DC string, particularly in series, there are many systems that are even 5 years old that can't be upgraded simply because that manufacturer doesn't make that panel anymore. So you have a choice to either replace the whole string, to look at optimizing a new panel or to look at replacing the whole system. Now, the beauty of the REA AC module is because we're parallel AC, it means that when we bring out a new module, you can actually plug it in with the existing system. If you have a failure and you have a replacement and we have a new module, you can connect that directly into the system and you won't have any issues where you will lose panels within the array. Okay, REA powered IQ8HC. So integrating the AC, the ACM and the microinverter might sound simple. It took us 4 years with development with Enphase. Now, COVID didn't help with this, but what we did was work closely with Enphase to develop the best module for the microinverter. Now, the microinverter Enphase is known as the best system on the market when it comes to inverter technology. I think most installers will agree with me. They may sell other products, but they put Enphase on their own home. I think you, Finn, have Enphase on your home?
Yes.
Excellent. So I was hoping. So I have Enphase on my house. Most installers that I know put Enphase on their own home. So it is widely known that it is, yes, it's premium, but it is the best inverter technology on the market. So we worked with them to get the very best out of the microinverter. And rather than trying to just make a panel work with Enphase or make it compatible, we want to actually design a panel around the Enphase microinverter to get the most out of it. So our research and development with the Enphase team was started with the performance of the product, but also the reliability and destruction testing to make sure it didn't fall off, to make sure that both the micro and the panel didn't have any adverse effect on each other's warranty or reliability. So it took a long time. Eventually, we were able to get through with and pass with flying colors, and we're one of the very few manufacturers to pass all of their quality assurance testing. So it's a great achievement that a small Australian company can do that. Okay, so we got a little bit of a comparison here between an AC architecture or AC module and DC and optimized DC. So some of these things might have changed, but in a nutshell, it's design flexibility, it's increased performance, it's safety and reliability. And the safety piece in particular is really important because it is the only true circuit protected solar system. So if there is any issue with the system, if emergency services need to attend the property, when they pull that fuse in the street, the whole system is de-energized. It is the only system to be able to do that with AC architecture. Now, optimizers do a similar function with rapid shutdown, a little bit different, but they still have high voltage DC within the array, so it's a little bit different. The AC system simplifies it, so we have less components and we have a more reliable, safer, high performing system. Thank you. Any questions?
I have a question on the facial part of your panel.
Yes.
You said you have this BNPI rating, but in real life, how much, especially for flash mount, because most of the panels will be flash mounted.
Yeah.
Any difference?
Yeah, definitely. So, so if we're looking at just a flash test or peak output, okay, you're generally looking, even with our testing on a dark coloured roof with only 90 mil space between the roof itself and the panel, we were still seeing between 2 and 3% uptake in performance. But what we were seeing is as little as 15 minutes to 30 minutes additional daily performance. Now that might only be at 10%, but when you multiply that throughout the whole year, you're getting more yield out of the system. So we started with the development of this panel back in 2014, on paper, when you're looking at the actual potential bifaciality or reflection of the roof, it doesn't make sense, but in real world applications, when we're looking at comparative systems, we are generating more performance. But when our power partners, and we'll talk about the power partners and how we choose them, but essentially when our power partners and when we sell the product, we sell it on the front face only. So we don't actually give you the exact performance additional output that is just a bonus because, like you say, it is really hard to give exact figures from property to property. So what we say is we've developed this to do the best we possibly can to produce as much as we can with that roof space, but you only pay for the front side.
Just following on that question,
Yeah.
If you have a tin roof
Yeah.
versus a tile roof, would
Yes.
you see much difference in performance?
Yeah, so
and also color of the roof probably makes it different.
definitely, yeah. So generally, you know, we see up to 10% additional reflection even without till kits on a white roof. So a white metal roof or color surf mist roof. We're seeing 15 to 18% when it is actually tilted. So we're able to, if we have a flat roof and we're tilting it to 27 degrees, we're getting up to 18% additional output.
So the optimal roof would be like a surf mist color tin.
Yeah, a light color. Yeah, definitely. A light color roof would
Dark
be.
color would absorb the light.
Yeah, that's right. And within the reason why it is transparent as well is we're wanting to achieve the aesthetics of a black module without actually having that temperature degradation under heat as well. So we're able to dissipate more heat with the transparent dual glass as opposed to just having a black back sheet. And Luke will attest to this. When it is on the roof and you get the reflection of the light, the panel looks completely black. Yeah, so we're trying to get the best of aesthetics, but not dropping in actual yield.
We've got the two panels on the end are both the REA Fusion, so we've got one front and back, so you can see the microinverter there. And as well, if you look on the screen up here, we've actually got REA Fusion panels on the roof directly above you, so you can see the data on the screen here and you can see the production of the panels here as well. So yeah, we've installed them, yeah, great results so far. So we've compared, I've got another solar edge system at the back and there's panels that are doing worse, definitely. So compared to Giga, there was one panel that was pretty comparable actually when I checked just then.
Yeah.
I think it was, I have to double check.
Yeah, okay, that's all good. So I wanted to talk quickly about our power partners. Obviously, Luke has been chosen as a power partner, and similar to my colleague who will be up next, you know, we spent a lot of time, and we have over the last 12 months, in how we roll out this product. So what we did was we installed thousands of the panels, which we have in the market with panel level data and monitoring for our R&D. We have REA Solar in Southeast Queensland, which is the retailer for REA Power. I'm the founder of both, but they're separate companies. So REA Solar is the lightning energy of Southeast Queensland. So what we wanted to do was we wanted to run it for a long time ourselves to make sure that it was high performing, that it was reliable. And now we're confident in releasing it out to the market. And we spent more than 12 months in looking at who would be the power partners for us. So companies that aligned with our vision and values, in-house installation companies that could support our customers both in the quality of installation and the support, because we can have the best product in the world, but if it is installed by cowboys and not supported, we're going to get a bad name. So that's why we chose Lightning Energy as our exclusive partner in this area, and that is a testament to Luke and his team on the business that he's built now.
This critical relates to both you and solar guides.
Yeah, yep.
There's no info on the panels and solar guides.
Yeah.
I was just saying, this relates to both you and Finn.
Yes.
There's no info on this. I'm guessing because just only a few partners have access to this panel. Because
Correct.
About it on, like, there's only REC, SunPower, and
Yeah, so to start off with, we have flown under the radar for a long time. We actually released the product in the UK first. So if you search like any of the Electrify shows and stuff like that, where they test panels, and the witch.com, which is massive in the UK, product review, we're actually the #1 rated panel now in the UK. We have flown under the radar in Australia until we are happy to release it to the market, which we are doing now. So you will start to see more reviews, you'll start to see more people talking about the product. It is exclusive, so we choose who represents the product and we support them. So you can't just buy it from anyone. It's not available through any distributor or wholesaler. And we've decided to do that because we have a limited manufacturing capacity in Australia. So we want that to be the best possible solution for the customers. Question?
obviously you've got a bit of scarcity in that you're only going through limited supply.
Yeah.
How's the price compare?
Yeah, so in terms of, if you look at it, obviously a DC module versus our module, we're a lot more expensive simply because we're an AC module. You don't need the inverter. When you're looking at pairing any panel on the market with an off-the-shelf IQ8HC, we're within 10% of the market for a properly designed, integrated, Australian assembled AC module. When we talk AC architecture versus DC or hybrid systems, Luke will be able to answer the difference. I personally believe that when you look at the levelized cost of ownership, the fact that we have a 25-year full replacement warranty across the whole system, that cost per kilowatt hour of actual generated energy should work out cheaper in the long run.
Luke, 10 kilowatt, Trina, Fronius, Gen 24 versus 10 kilowatt REA. What's the price difference?
Sales team, you guys are on it every day.
30, 40, 30% then?
30%.
Maybe a little bit more.
Right.
Yeah, about 30.
Comparing it to a Fronius, I'll grab.
I suppose the safety feature is one of your key selling points.
Well, yeah, I and Finn might disagree, everyone might disagree, but I wouldn't buy a car with no airbags or seatbelts just because it was half the price. And essentially, I believe that we should have full circuit protection. There's nothing else in the home that is not circuit protected except for a solar system, which is really strange. So you pay for that circuit protection, you pay for the 25-year warranty. Also, in terms of maintenance costs, when you look at every single other manufacturer's warranty document, they now require between 6 and 12-month maintenance, and it needs to be documented because there are a lot of warranty claims that are being voided simply because of shading, because of soiling on panels, hotspots, all sorts of things happening, and if you give them any chance or anything to actually combat a warranty claim, they will. When you bring in and you add that warranty, that maintenance schedule in, and you look at that levelized cost of ownership, it should be comparable.
Look, I think you've got to be comparing apples and apples here. I think comparing it to, and it's an Enphase system compared to a string system, which I don't think is necessarily a fair comparison because, look, Michael's just mentioned that Enphase has a huge amount of benefits above and beyond DC. If you're comparing REA panels to just coupling Enphase to Jinko and Trina, or like historically our top-selling panel, our premium panel recently was the SunPower Maxi and 6. I reckon we're cheaper than that now. So compared to a panel that has an AC module built in, or something where you've just slapped an AC module against a mid-range panel, it's actually pretty good.
So compared to Maxi and 6, which has built-in microinverters as well, this is a much better option, right?
Much better option. They're not going bankrupt, so.
Yeah, well,
well, Maxi and Maxian's
expensive.
technically not going bankrupt. SunPower has.
We're cheaper than Maxion, and Enphase. Just ask Enphase.
Yeah.
Call Enphase and ask them who they.
Like 25 years warranty on the microinverters.
Exactly. So we developed this in partnership with Enphase. We didn't buy the micro and get permission to stick it on the panel. So even the position of the micro is completely different, and that's to help the actual installation and reliability of the product. We spent a year just on the placement of that microinverter. So.
Aren't you guys in the US market by now?
COVID.
Just a quick one. You've mentioned that the potential fire and stuff with DC. Have you got any statistics on that across the installations of occurrences where fires have been caused?
Yeah, so what's quite interesting is that both in Australia and the UK, a lot of the statistics, particularly with renewable energy, is actually categorized as electrical fire. So there is more happening at the moment to separate that and segregate that. Finn might have more statistics on it. If it's more than 0, it's not acceptable, and it definitely is, and it is getting bigger.
So just following on from that, am I reading into this that people with DC systems may in future be paying higher premiums for their insurance?
That's the rumours. That's the rumours in terms of what everything I've heard on the street in terms of addressing this issue is the fact. Obviously, the government have an issue where, similar to installation, they're tied in with government programs and financial assistance, so they're reluctant to dive too much into this. If it is pushed back onto the private sector, it's like anything. If anything is no longer compliant to current standards, then it generally goes on to insurance, where they increase a premium or no longer offer support for that particular property. But nothing's confirmed yet. So,
are you asking around how often do systems statistically catch on fire?
Yeah.
Yeah.
How many of you guys have caught fire your DC systems?
0, but I'll tell you a few stories about that. So how many systems have we been called out to that have caught on fire from other installers in the last few years? 3 or 4, to be honest. And coincidentally, had I not been in this industry, my brother-in-law who lives in New South Wales, his DC isolator caught on fire 2 weeks ago. DC isolators are no longer a thing now. They removed the regulation around that, so technically that wouldn't have happened.
Rooftop DC isolator.
Yeah, rooftop DC isolator. Yes, thank you, Finn. That's why we invited him. But yeah, so look, it does happen. It's one of those things. To be honest, it's probably unlikely that it's going to happen, but it's your house, it's DC. Do you want to risk it? What's it worth to you?
Risk it.
yeah, if you're really interested, definitely contact emergency services. Particularly Queensland Fire Service released some data. It was in around the number of 400 fires which were directly caused by solar in Queensland.
Did they say recently 1 a day in Queensland?
Yeah. So it's happening. It's getting bigger. One of the biggest things and the differences is that 10, 15 years ago we were installing 1 kilowatt systems with less than 200 volts direct current. Now they're 500, 600, and with new standards up to 1,000 volts DC. So that can melt. That DC arc fault is over 2,000 degrees and can melt tungsten. So if you think that you won't ever get a rodent in your roof to chew a cable, or all of the plastic connecting plugs of the panels, the isolators, everything else within the system will last 20, 30 years, then you shouldn't have an issue. But like I said before, it's not 0. So REA, it's not good enough. So, we want to have a completely circuit protected system, and that's what we believe.
Any more questions?
Isn't you just cut half of your market? Let's say maybe not half, maybe even more.
Mm-hmm.
In theory, you can build the same panel this year, right? Just remove the Enphase.
Yeah, it's a good question. So because all of our R&D and development has been around AC modules and being different, the Chinese do a great job of building a DC panel, and you can buy it, and it's great. But we want to be different. We want to be able to guarantee to the customer that they will never have a problem with safety. So if we do bring out a DC module, which we are in R&D development, it will be a smart module, so we still can comply with rapid shutdown.
So essentially, install optimizers there.
Yeah, it'd be an integrated optimizer. So, like I say, I'm not against DC, not at all. This is the path that we have gone down. This is what I believe. I believe AC architecture in the long run as well performs additional benefits when integrating battery storage as the uptake increases, because your solar and your battery essentially are 2 separate systems. So if you have your solar down, you still have your battery. If your battery's down, you still have your solar. They're also working 50% as hard. So if you have a hybrid system with a hybrid inverter, it will be operating for 24 hours a day, controlling the solar panels and the charge and discharge of the battery storage. So when you AC couple a system, you lose a couple of % of efficiency, but what you gain massively is that potential reliability piece.
Question? Yeah.
Is there any impact going into a battery? Any changes to go into, say, a power wall? Or?
No. So think of the AC system as just an AC circuit. So batteries are now being installed without solar. So they're just getting connected with an AC circuit, providing that the battery can be AC coupled and charged from any AC source, then we can use our AC module system with it.
Just on that though, I mentioned before, so the Powerwall 3, they've just got approved by the CEC, so you can install it now, but I believe it's not approved for retrofits with Enphase installations currently, so they need to resubmit to the CEC, so it's a whole government regulatory thing. I don't want to bore you, but you might not be able to AC couple a Powerwall 3 to REA panels at this point until you either bring out the DC optimised panels soon, or you could have a Powerwall 2 with REA panels.
Yeah, so in the UK we AC couple it, and so everything's fine there. It's just there's a little bit of red tape here in regards to how they submitted their application. So we're working through that at the moment to make sure we solve that. In addition to that, we are going to be releasing our power bank, which is our own battery. That's an AC coupled battery, modular battery that will obviously work harmoniously with our panels.
Considering
You got a loud voice anyway, so you're not too bad.
considering the fact that this is it's got inbuilt, the panels got inbuilt microinverters, why would you bother with Tesla Powerwall 3? Because that's got its own inverter, so you're paying for something you're not going to be using though. Does that like you're just better off with Powerwall 2?
Powerwall 2. We love Powerwall 2.
Yeah.
So what we when we finish our testing, which we've done over 1,000 batteries in the UK, we will finish our in-house testing. Maybe February we will launch the power bank. We love the Powerwall 2, put it that way. Powerwall 2 are discontinuing it, so REA is going to bring out an AC coupled,
It depends on your scenario. So you've got a higher power output from the Powerwall 3 and different battery chemistry as well.
Right.
So some people may prefer that. It also costs $1,500 more. So the few benefits you get from Powerwall 3 may not be worth it. So there is still place for the Powerwall 2, but the Powerwall 2 is being discontinued by the end of the year. So then it's going to be a discussion of if you chuck a Powerwall 3 in and it's kind of overkill. It can kind of do anything, but then it'll have an inverter that you're not using, maybe. It all depends on the situation. There's
one benefit is you could have two different systems, one Enphase, another one just DC directly into the Powerwall, like for cold start.
Well, that's actually something that, we are doing. So retrofitting, we're trialling one site. I think we've got a few coming up. We are looking at trying to retrofit. I'm hesitant to say this because the CEC threw a spanner in the works this week, but we're trying to retrofit a Powerwall 3 to an Enphase system with then solar connected to the DC inverter of the Powerwall 3 at the same time. So exactly what you said, so DC-AC coupling, but technically due to regulatory issues, it's non-compliant. So we need the Department of Government Efficiency here to sort that one out.
Yeah, so ultimately there's some cost efficiencies, particularly with batteries and manufacturing partnerships. There's only a few big players of battery cells. So in terms of solution, particularly from Q1 next year, if we can deliver, it's our job to be able to deliver a complete AC coupled solution for the same cost per kilowatt hour as a DC system directly into a Powerwall 3. If we can deliver that, then we have a fully circuit protected system that's safer and potentially more reliable.
Any problems with coupling batteries AC, essentially coupling AC batteries and Enphase on maximum inverter side? Because essentially you have 10 kilowatts on the roof from Enphase and 10 kilowatts from the battery.
Yeah, for sure. So when you AC couple, obviously there isn't that oversizing rule. So when you're installing a hybrid system, you can install up to 200% essentially of its rating. So with a Powerwall 3, you can connect 20 kilowatts of PV.
But you're talking about inverter size of it.
Yeah, I'm talking about the
DNS
provider.
Yeah. So obviously, when you are doing your application, particularly in single phase, there will be some restrictions there, and Luke's team will be able to calculate what would be the best for your solution.
What is it here, Luke? 10 kilowatts of solar and 10 kilowatt battery, or do they class the?
10. It's well, they've changed it now with the backstop, but usually it's 5 kilowatts per phase, and yeah, 5 kilowatts battery. But we should be able to go 5. I think it's 5 plus 10 now on the batteries. 5 kilowatts of solar, 10 kilowatt battery inverter. It's complicated. There's 5 different networks.
Okay, it's just adding two.
Yeah, different.
Any other questions?
I've got a question. What took 4 years to integrate the?
COVID was a big part of it. It was right. It was basically 6 months before the start.
What do you optimize on the? What do you optimize on the panel to get it to work better with the? Electrically.
Yeah, for sure. So when we're looking at in terms of cells, when manufacturers are looking at choosing the type of cell. When you have just cell layouts, whether it's 96 cells or 108 cells, what we look at is obviously then the finished voltage and current profile of the actual panel. So what we do is we looked at the next generation of microinverters, both the IQ8 currently and the future IQ9, and work on designing a panel that will turn on earlier and turn off later to have a better profile within its maximum power point voltage and also its current profile. So it's really just designing it to match perfectly with minimizing clipping or any other operational issues. Yeah, so in summary, we work to look at bringing out the best product that we can to the market. We leverage both government, university, and also component manufacturing partners globally to be able to deliver the best products on the market. How we do that at our size and scale is by leveraging contract manufacturing, but also working with these component manufacturers to partner in a way that we can release product before they can. Because we're small and nimble, we're able to take better cells, better silicon, better products, and deliver it to the market even before our component manufacturing partners.
Cool. All right. Well, thanks for that, Michael. Very informative. Hope you guys enjoyed it.